Journey through the wonderland of mathematics.
Mathematics? That's for eggheads.
Eggheads? Now hold on, Donald. You like music, don't you?
Yeah?
Well, without eggheads, there would be no music. Come on. Let's go to ancient Greece, to the time of Pythagoras, the master egghead of them all.
Pythagoras?
The father of mathematics and music.
Mathematics and music?
Ah, you'll find mathematics in the darndest places. Watch. First, we'll need a string. Stretch it good and tight, plunk it. Now divide in half. Plunk again. You see? It's the same tone, one octave higher. Now divide the next section. And the next. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. And from this harmony in numbers developed the musical scale of today.
By golly, you do find mathematics in the darndest places.
Shape. It can mathematically reproduce itself indefinitely. All these rectangles have exactly the same proportions. This figure also contains a magic spiral that repeats the proportions of the golden section into infinity. To the Greeks, the golden rectangle represented a mathematical law of beauty. We find it in their classical architecture. The Parthenon, perhaps one of the most famous of early Greek buildings, contains many golden rectangles. These same golden proportions are also found in their sculpture. In the centuries that followed, the golden rectangle dominated the idea of beauty in architecture throughout the Western world. The Cathedral of Notre Dame is an outstanding example. The Renaissance painters knew this secret well. Today, the golden rectangle is very much a part of our modern world. Modern painters have rediscovered the magic of these proportions. Indeed, this ideal proportion is to be found in life itself.
Boy, oh boy, oh boy. This is mathematics. I like mathematical figures like that.
Donald.
Get me to it.
No.
Ideal proportion.
Not quite. No, I'm afraid not. Well, we can't all be mathematically perfect.
Oh, yeah? Yeah, I do like to do it.
Well, Donald, did you enjoy your geometrical journey?
Gee, Mr. Spirit, there's a lot more to mathematics than 2 times 2.
That's right, Donald. And you can find mathematics in games, too.
Games?
Mathematical game played on a field of 2 perfect squares, using 3 perfect spheres, and a lot of diamonds. In other words, billiards.
Oh, boy. That's for me.
You know the game, don't you, Donald?
Of course. The cue ball has to hit the other 2 balls. Like this.
Now let's see how an expert at 3-cushion billiards uses his head.
3-cushion?
Yes. The cue ball not only has to hit both the other balls, but it must contact at least 3 cushions before it hits the final ball. One, two, three. Oh, this game takes precise calculation. He figures out each shot in his head. He could play it like this, but it calls for quite a bit of luck. There is a better choice. For this, he uses the diamond markings on the rail as a mathematical guide. First, he figures the natural angle for hitting the object balls. And then he finds that his cue ball must bounce off the number